Y'all, I just learned a thing. It's really cool. I wanted to share. So it turns out you can use the same box method we use to multiply polynomials to divide them. And it's way simpler than trying to parse out long division, and kind of helps make some sense around synthetic division as well. Before we talk about it, let's back up, right? And let's talk about why the box method works and why a lot of kids seem to resonate with it. Because one of the ways they learn to multiply complex numbers in elementary school is with this array, and they decompose the numbers. So instead of 427, they're going to write it out as 400 plus 20 plus 7 and 30 plus 8. So now we're really only working with single digit multiplication, and we're just going to track our place value. So 4 times 3 is 12. And if I want to keep track of place value, I can think of it as tens, hundreds, thousands, and place that in there. 3 times 2 is 6, tens, hundreds, 600. 3 times 7 is 21, tens. 8 times 4, 32, hundreds. 8 times 2, 16, tens. And 8 times 7 is 56. Now I could just add all 6 of these numbers together, but that kind of turns into an excessive amount. So if I pre-look ahead, these were hundreds, these were hundreds. So if I add those together, I get 3,800. These were tens, add those together, 370. And then I only have to do the 4, 12,000, 3,800, 370, and 56. And this is a little more manageable to add. 6, 12, 12, 6, 16,226. It makes more sense than the standard algorithm. We're getting the same values that we're adding together. It's just a simplification of the process, right? It's more accessible. And the exact same thing is happening when we do it with polynomials, right? 3 times 4 is 12. There's an x here, and this is x times x, so we end up with 12 x times x times x, which we can shorthand as x cubed. X times x times x, that's 10 cubed, right? Again, my like terms line up if I've written these in standard form. So 6 and 32 is 38x squareds. Here was our 3,800. 16x and 21x, 37x. Remember our 370 or 37 tens. And our 56 is exactly the same. So we can write 12x cubed plus 38x squared plus 37x plus 56. Here's where it gets cool. This is the new part. We're going to undo that problem we just did. Okay, so we're going to set it up as division. 12x squared plus 38x, or excuse me, 12x cubed plus 38x squared plus 37x plus 56 divided by 3x plus 8. So here's my 3x plus 8 over here. And I know that that 12x cubed had to come from this top left box. We're going to work backwards. So 3 times what is 12? That's 4. I have an x, I need it to be x cubed, so this has to be x squared. If I know this 4x squared, then I can multiply to fill this bottom box. 4 times 8 is 32, x squared times that is x squared. Now I know that my other x squared should be here, and that when I combine these two together, it should equal 38x squared. What's missing? Darker color is 6x squareds. So now 32 plus my 6 is going to give me my 38. 3x times what is 6x squared? 2x. And then if I know 2x, I can multiply to fill this bottom box. 2x times 8 is 16x. I know that my other x term should be here, and when I combine these together, it should equal 37x. What's missing is 21x. If I know 3x times 7 to give me 21x, and 7 times 8 is 56. When I check on that 56, I can verify this last term matches, so I know I'm finished. And my final answer then, 4x squared plus 2x plus 7. Okay, and again, I could be asking, is this a factor? Right? I know it's a factor if I divide and get 0. So let's set that up. 5x, negative 4, and I know that 5x squared should be here. Well, 5x times what is 5x squared? I can write the 1 with the x. X times x, there's my x squared. 1 times 5 is 5. If I know the 1x, I'm going to multiply to fill this bottom box. I get negative 4x. I know my other x term should be here, and when I combine them, I should get 26x. 4x combined with what gives me 26? 30x. If I have 5x and 30x and I need to multiply, 5 times 6 is 30, and then bring my x. Negative 4 times 6 is negative 24, and that negative 24 is this final value. So my end result, if I do the division, is 1x plus 6. Is it a factor? Yes, because the remainder is 0. There is no remainder. So what happens if there is a remainder? Well, the same thing that happens in long division. We're going to set up x negative 5, 2x squared, and we're ready to start filling in. X times what is 2x squared? X times 2x is 2x squared. Multiply to fill. 2x times negative 5 is negative 10x. Negative 10x plus something is negative 13, so I need negative 3x. What do I multiply by? X times negative 3 gives me negative 3x. Negative 3 times negative 5 is positive 15. That positive 15 is not the 5 we needed. How do I fix it? Well, I fix it by subtracting 10. So my final answer, 2x minus 3 minus 10 over x minus 5. It's exactly the same thing we do with long division, right? We take whatever that number was that was left and put it over what we divided by. So try these two, right? 4x squared minus 5x minus 21 divided by x minus 3. We could be just dividing. We could be asking, is it a factor? 3x cubed plus 16x plus 11x plus 3 divided by x squared plus 5x plus 2. Again, we might want to know if it's a factor. We might just want to be dividing. One of these has a remainder, the other does not. Go ahead and hit pause. And come back and we'll check our work. So I know that x minus 3 is not a factor of 4x squared minus 5x minus 24 because we had this remainder. I had to resolve the negative 21 to negative 24 and my final answer. But x squared plus 5x plus 2 is a factor of 3x cubed plus 16x plus 11x plus 2 because my constant term matches, there is no remainder. Thanks for hanging out. Definitely let me know if you want to play with this some more or have any questions.